right now. If you hand a group of Wall Street investors $40 billion and tell them to build an advanced semiconductor factory on American soil, you aren't giving them a license to print money, you are handing them a financial trap. Most people assume owning a U.S. chip factory is the ultimate money-making machine of our era. But if you bought one today, you'd instantly discover that before you slice a single silicon wafer, you are already bleeding millions of dollars every single hour. And the clock started ticking the second you signed the contract. So, why are the world's most powerful tech giants and sovereign governments fighting tooth and nail, risking hundreds of billions? To build these massive financial traps on U.S. soil, where does the money actually come from? When a single machine inside the building costs more than a commercial airliner. And what is the terrifying financial secret that every single chip maker knows, but almost no outsider ever sees? To understand this systemic illusion, we have to break open the darkest accounting reality in modern capitalism. When you look at companies like Apple, Nvidia, or Microsoft, you see trillion-dollar empires built on brilliant code and sleek designs, but sitting quietly underneath the entire global economy is a slab of ultra-pure silicon, smaller than a human fingernail, packed with billions of microscopic pathways. Today, the global semiconductor market is racing toward $1 trillion. It is the invisible brain behind every hospital grid, autonomous vehicle, artificial intelligence server, and national defense system on Earth. Yet, for decades, America let the physical manufacturing of these vital components slip across the ocean. Today, the vast majority of advanced chips are made thousands of miles away, on a single, geographically vulnerable island. To fix this, politicians passed historic legislation, dumping over $50 billion of government cash into domestic chip manufacturing. On TV, it looks like a triumphant corporate victory, but behind closed doors, inside the offices of corporate CFOs, a completely different emotion was taking over: sheer financial terror, because building a factory on American soil isn't just about laying concrete and hiring engineers. In fact, the moment you attempt to build one of these facilities, you realize you aren't running a traditional business at all. You see, an advanced chip factory, or fab, does not operate like a steel mill or an auto plant. The ownership model is a complex web of private corporations, institutional investors, and deep-pocketed tech clients. To get a facility built on U.S. soil today, you don't just use your own cash, you assemble a delicate puzzle of federal grants, local tax breaks, corporate debt, and customer prepayments. But here is the trap. Accepting that money binds you to strict political, environmental, and operational rules that can crush your profit margins before you produce a single working chip. The entities funding these fabs aren't doing it out of patriotism. They are doing it because without these chips, their entire multi-trillion-dollar domestic ecosystems could collapse overnight. Yet, the financial risk falls almost entirely on the operator. If the factory pauses for even a few minutes, the losses don't accumulate by the day, they accumulate by the second. Which brings us to an impossible question. How do you actually make money on something that costs $20 billion just to open the front door? To understand the revenue engine, forget everything you know about standard manufacturing. Chip factories don't sell products to everyday consumers. They sell guaranteed manufacturing capacity, measured in microscopic precision, to tech giants who design chips but refuse to build them. Think of a fab like an ultra-exclusive, insanely expensive printing press. Tech companies send you their hyper-complex architectural blueprints, and you charge them exorbitant fees to print those designs onto silicon. The revenue flows in through massive, multi-year capacity agreements. Companies will literally pay hundreds of millions of dollars upfront just to reserve a spot on your production line 2 years from now. And every single wafer of silicon that rolls off that line can sell for $10, $20, or even $30,000, containing hundreds of individual chips destined for high-end AI servers and flagship smartphones. On paper, it sounds like an unstoppable money machine, but that is only the surface. Because the real fortune isn't made on the silicon itself. The hidden profit driver, The secret mechanism that transforms a massive liability into a cash-printing monopoly is something known as the yield curve. When a brand new, cutting-edge facility opens, up to 80% of the chips produced might actually be defective, literally useless waste, but as engineers spend months tuning the lasers, tweaking chemical flows, and adjusting precision mirrors, that defect rate plunges. Once your yield hits 90%, something incredible happens. Your operating expenses stay virtually the same, but every extra percentage point of usable silicon drops straight to your bottom line as pure cash. That is where the hidden fortunes are made, not by building more factories, but by mastering the invisible art of micro-yield optimization. And then comes the power of switching costs. Once a major tech firm designs a chip specifically for your factory's exact manufacturing process, it can take them 2 years and hundreds of millions of dollars to switch to a competitor. You don't just have customers, you have captives. However, before you start counting those billions, you have to look at the terrifying wall of expenses waiting on the other side. The cost structure of a US chip factory is unlike anything else in modern business. The moment the doors open, you enter a relentless, high-stakes race against depreciation. The machinery inside these buildings, specifically the extreme ultraviolet lithography systems, are among the most complex devices ever created by human beings. A single machine can cost upwards of $200 million, requiring multiple cargo planes just to deliver, and these machines don't last forever. In fact, within 5 to 7 years, technology advances so fast that your multi-billion-dollar equipment becomes functionally obsolete. That means your factory has to earn back its entire multi-billion-dollar investment, plus interest, in an insanely tight time window. Then add the operational overhead. A single advanced facility consumes millions of gallons of hyper-purified water every single day. Along with enough electricity to power a small city, add in the cost of top-tier raw materials, strict environmental compliance in the US, and a scarce workforce of specialized engineers, and your fixed baseline expenses are staggering, whether you are producing chips or standing idle. This explains why small players simply cannot survive in this industry. The cost of entry isn't just high, it is practically insurmountable. This brings us to the brutal dynamic of scale. In this business, you are either massive or you are extinct. Billion-dollar operators dominate because of extreme economies of scale. When you operate multiple facilities, you can spread the monstrous research and development costs across tens of millions of chips, drastically lowering the cost per unit. You gain immense bargaining power over suppliers of raw silicon, specialty gases, and rare optics. You build deep network effects with software designers who optimize their tools specifically for your manufacturing ecosystem. This creates an almost unbreakable barrier to entry. A newcomer cannot simply start small and grow naturally. You either enter with tens of billions of dollars and immediate global scale, or you don't enter at all. Yet, even for the giants who dominate this space, the entire industry sits on the edge of a razor-sharp blade. The risks facing a US-based chip factory are catastrophic and unpredictable. First, there is the brutal threat of economic cycles. Semiconductor demand is notoriously volatile. If tech giants overorder during a boom, they leave you sitting on empty production capacity during a downturn, while your fixed costs continue to burn millions a day. Second, geopolitical tension and supply chain fragility. Even if your factory is safely located in the United States, your raw materials, specialized chemical reagents, and precision subcomponents are sourced from a fragile, multi-country web. A single disruption anywhere on the planet can freeze your entire operation. And finally, there is the constant, terrifying threat of technological leapfrogging. If a competitor masters a smaller, faster, or more efficient manufacturing node before you, your expensive, state-of-the-art facility can turn into an outdated relic almost overnight. So, as we look into the future, where is this high-stakes game actually heading? We are entering an era driven by artificial intelligence, unprecedented automation, and intense geopolitical rivalry. The demand for raw processing power is exploding faster than at any point in human history. Fabs are becoming fully automated sanctuaries where human intervention is minimized to prevent even a single speck of dust from ruining a wafer. And AI systems are now being used to design the very next generation of manufacturing processes. Governments around the globe are spending hundreds of billions in subsidies to secure domestic supply chains, transforming chip manufacturing from a mere commercial industry into the core foundation of national sovereignty. So, when you look at a U.S. chip factory, don't just see a large building filled with concrete and high-tech tools. See it for what it truly is, a high-stakes, hyper-fragile gamble where humanity pushes physics to its absolute limits, spending billions of dollars to manipulate atoms, simply to power the invisible brain of our modern world. The people who own these factories aren't just selling tech components. They are controlling the ultimate bottleneck of human progress, and in the modern world, whoever controls the bottleneck controls the future.